is the new topic on which questions are increasing is about geomagnetism. See guys, if I have to make a magnet, I should have iron particles. To this iron particles, if battery is connected, charged particles will go through this. And the charged particles, when they touch the iron, it will become electromagnet, and it will have its own field called as electromagnetic field. Same way, if we consider inner core is made up of nickel and iron, and around it you will have outer core. Outer core is mostly in liquid form. The interaction between inner core and outer core has led to what we call as geomagnetic field. Okay, so I'll tell the words, please write down. Geomagnetic field hyphen. The interaction between inner core and outer core leads to geomagnetic field. Next point, most of the planets has magnetic field. The characteristics required for magnetic field are first one, the planet must be rotating faster, very important. The planet must be rotating faster. Remember, if the planet is not rotating faster, there is no magnetic field. Rotating faster. Second, there must be liquid layer inside. Underline liquid layer. There must be liquid layer inside. Third, there must be circulation inside the liquid layer. Fourth, there must be conduction between liquid layer and other layers. Okay. Benefits. What are the benefits of geomagnetic field? Do you recollect Earth lost primordial atmosphere to solar wind? Yes, you write below. It protects Earth's atmosphere from solar wind. Second point, it protects satellites and other communications. Next, it will not allow harmful particles from sun and other stars from reaching the earth. Next point, interaction between Earth's magnetic field and solar wind leads to aurora borealis. Have you heard? Aurora borealis and aurora australis. It is also called northern lights and southern lights. Underline the two words there. Interaction between which two? Solar wind and Earth's magnetic field. Please understand, it is not between ionosphere. Ionosphere is not important. What is important? Like, Earth's magnetic field is important. Guys, can you tell me where do you have more geomagnetic field? Can I say more geomagnetic field will be near the poles? So if more geomagnetic field is near the poles, like, we normally observe what you call it as auroras mostly in the poles. But recently in Ladakh, we have kept a telescope. And from that telescope, we have identified that auroras are present near equator also. That was the reason question was asked in exam. Okay. So you write there, auroras are present mostly near poles because there is high density of magnetic field. But in recent years it is found near equator as well. Done? Okay. Last. See here. If we take Earth, 90 degree north, 90 degrees south. This is called geographic north, geographic south. Geomagnetic north, magnetic south. Where it goes out is called as geomagnetic north. Where it comes inside is called as what? Geomagnetic south. Please see here, geographic north and south are different from geomagnetic north and south. Geographic north and south are fixed, latitudes are fixed. What is changing? Geomagnetic north and south is not constant. It keeps changing. These two words are important, you write? Geographic north and south are different from geomagnetic north and south. Magnetic north and south. Next point, geographic north and south geographic north and south is fixed, whereas geomagnetic north and south, magnetic north and south shifts. Are you getting the point? Yes. You see here, if this is Earth, this is geomagnetic field. See, where the lines are present, we call it as geomagnetic field. Where it has extended beyond, magnetosphere. What is it called? Magnetosphere. Can I say magnetosphere is extended? Yes. What is the role of magnetosphere? It will hold harmful particles. It doesn't allow harmful particles to come. Okay? It will hold harmful particles. That is called Van Allen belts. Okay? Van Allen belt is harmful particles held by Earth's magnetosphere. And there will be two Van Allen belts, inner Van Allen belt and outer Van Allen belt. Okay, two things is, one is what? Auroras are due to interaction between solar wind and geomagnetic field. Second, like magnetosphere holds harmful particles called as Van Allen belts. Fine. Next, shall I? Sea floor spreading. Yes. Seafloor spreading was studied with respect to Atlantic Ocean. What did they observe? They observed at the center of Atlantic Ocean, there will be mid-Atlantic ridges. Exactly at the center, you will have mid-Atlantic ridges. And these are active. They are active. These mid-Atlantic ridges are in S shape. Okay. They are present in Arctic to Antarctic almost. And these ridges extend into Indian Ocean and Pacific Ocean also. Which one? Ridges. From Atlantic, they enter into Indian Ocean also, Pacific Ocean also. Okay. So, if I call this as South America, and Africa. At the bottom, have sediments like this. Sediment thickness decreases from continent to ridge. The thickness of the sediments decreases from continent till the ridge. This was done 50 million years ago, 100 million years ago, 150 million years ago, 50 million years ago, what is the meaning of this? Age of oceanic crust decreases from continent till the ridge. Okay? Age decreases from continent till ridge. Okay, 4 points will come in seafloor spreading. What is the first point? At the center of Atlantic Ocean, we have mid-Atlantic ridges. Okay. Second point is sediment thickness decreases from continent till the ridge. Third point is age decreases from continent till the ridge. And then if we look at iron particles alignment, it is alternatively arranged indicating magnetic anomaly. Magnetic anomaly means, you see, iron particles, they will arrange according to the Earth's magnetic field. So if entire crust is formed at the same time, all of them will be arranged in this direction. But if this is formed at a different time and this is formed at a different time, if one is in this direction, another one will be in this direction. So opposite direction alignment is called as magnetic anomaly. Okay, just remember the word magnetic anomaly. What are the 4 words of seafloor spreading? What are the 4 points? Exactly at the center, what do you have? Mid-Atlantic ridge. Are they active or passive? Active. Second, sedimentary thickness decreases from where to where? Continent to the ridge. Third, age decreases from where to where? Continent till the ridge. Fourth, there will be magnetic anomaly. So just you write below, from the above, it is understood that new crust is formed near the ridge. New crust is formed near the ridge. Second, continent is older. So you can write continent can be older than oceanic crust. Can be older than oceanic crust. Plate tectonics. Composition size is based on composition. It is divided into continent and ocean. Continent is made up of silica and aluminium, and it is 35 kilometer thick. Okay, 35 kilometer thick. Ocean is made up of silica and magnesium. It is 5 kilometer thick. Okay, if we go by size of the plate, major, minor plates, there are 7 major plates. North American plate, South American plate, Africa plate, Indo-Australia plate, Pacific plate, Eurasia plate, Antarctic plate. Some of the minor plates are Arabian plate, Philippines plate, Cocos plate, Nazca plate. There are many. 7 major you try to remember. This continent and ocean. Can we say ocean is denser compared to continent? Okay, ocean is denser compared to continent. Next, we'll talk about tectonics. Before I talk about tectonics, guys, if a lava comes and solidifies in cone shape, okay, if a lava comes and solidifies in cone shape, it is normally called volcanic mountain. Okay, solidifies in cone shape, it is called volcanic mountain. If it is in the form of anticline and syncline, then it is called as fold mountain. Block mountain. Steep slopes will be block mountain, anticline syncline will be fold mountain, and cone shape is volcanic mountain. Now, if I take the fold mountain, if at all height increases, it will be called as young fold mountains. If height decreases, old fold mountains. Yes. See, normally what happens if height is not increasing, exogenetic forces will reduce it. So height keeps on reducing. Any old fold mountains, height keeps on decreasing. Height will never be constant. If it is increasing, pressure is from inside. If it is decreasing, then it is old fold. Okay, now guys, based on this,